So today I'm going to discuss about variable inductance type transducer. Not like only variable inductance type. Also, I'll discuss some capacitive type transducer also. So here you can see in my last two classes, this in your sensor and transducer, I think all of you are able to understand. So what is the motivations for using different sensor circuit and transducer circuit and their applications. Okay, so basically you can observe that particular for it is normally the transducer or the sensor are normally designed for some particular applications. Okay, so for individual transducer or sensor having individual applications. Okay, so here you can see the variable inductance type transducers. Okay, so they normally what happens. So what do you mean by that? Inductive transducer, that we need to know first. Okay, so you know that is your inductive transducer. So inductance. Okay, so inductance is a property of the electrical circuit. So I think all of you know about it. Okay, so change the current flowing through that circuit induced an EMF. Okay, means electromotive force. Okay, so that EMF you can measure, okay, through a voltmeter. So but that amount of EMF developed, that amplitude is very less. Okay, so that's why all the time it is not possible to measure directly through the voltmeter. So some amplifications are required. Okay, so that after amplifications you are able to measure. So in this transducer you are using that phenomenon. So okay, so inductive transducer you are going to be use that phenomenon to measure that EMF. Okay, how do you develop that EMF? So you know that current or any of the circuit, that electric current I produce the magnetic field. Okay, then there is a flux development phi. Okay, in the circuit, magnetic flux according to Lenge's laws. Okay, tend to oppose the change of the flux by generating a voltage and counter EMF that tends to oppose the rate of change of current. Okay, so what is the motivation for developing that flux? Okay, so you can understand, due to the Lenge's law, the polarity may be different with your induced. That means the cause, always you know that effect is countering your cause. Okay, that's the concept. Okay, so you are much more focused about induced event. So that is called, again, if the in EMF is there, sorry, induced EMF is there, so inductance is the EMF is induced due to the presence of the changing of that inductance. So two type of inductance are available in the system. So you know that one, that self inductance. Another one is called mutual inductance. Okay, so these two inductance are there. For the self inductance, you know that inductance of the circuit due to the presence of that current. Okay, that current developed by that circuit. Okay, so in mutual inductance, what happens? When the varying flux field from one coil or circuit elements induce an EMF, okay, of the neighboring coils. Okay, so that mutual inductance normally observed due to the presence of the neighboring coils. Okay, and you can see that you can say like that circuit that affects is called that mutual inductance. Okay, so the magnetic reluctance or the magnetic resistance is analogous to resistances and electrical circuits. Okay, it is likely. So permeance, another thing is that what do you mean by that reluctance? Okay, so it is likely that electric field cause an electric current to flow the path of the least resistance. So magnetic resistance normally known as reluctance. Okay, that's why it is written a magnetic field cause a magnetic flux flow through the path at least magnetic reluctance. Okay, so flux only can flow through the least reluctance path. Okay, like your current is try to flow always least less resistance path. Okay, the same thing also happened for the magnetic circuit. It will, the current is always trying to flow through the least reluctance path. Okay, permeance is the reciprocal of that reluctance. Okay, so what is the variations of the self inductance? So how do you make it? So here you can see, if you check that circuit, so here you can see it is an electromagnet. Okay, so electromagnet is there. Okay, so electromagnet is there, and due to that electromagnet, that coiling is there. Okay, so you can see that color portion is your electromagnet. Here you can observe that coil. Okay, so coils are there, and the purpose of this coil, I think you know that purpose of this coil. There is an exciter. Exciter means voltage, additional voltage source is there. Okay, so now you can see it's another ferromagnetic bar. Okay, so ferromagnetic bar is there. Now the movement, that vertical movement you can observe. Okay, so vertical movement is there, and it's your air gap. So air gap means air core. Okay, so if the movement is different, so if you are making the movement, so it is called the measurement single self inductance arrangement. Okay, due to the movement, you can see the meter pointer will be deflected. Okay, the pointer will be deflected and you are able to measure that one. So it is single coil. So why single coil? Only one coil is there. That's why it is single coil. So when a single coil is used as a transducer element, okay, the mechanical input changes with the parameter, changes with the permeance of the flux path generated by the coil, thereby the changing of its inductance. So due to the changing of that air gap, so what happened, that inductance, that path of inductance, it will changing. Okay, so due to the changes of that value, due to the changes of this value, you can see that meter will be reflected. So another points, you can see that coils are there. Okay, so that coils are there. Okay, inductor coils are there. So you are catching or you are fetching the output from that coil. Okay, that is your slider, movable portion. So displacement is there. Okay, so displacement of that wiper or the slider. Okay, vertical displacement. Here you can see it is cylindrical. Means sorry, it is an circular path. Okay, circular path is there, then circular rotation, so it is rotational. Here you can see translational force, it is rotational, or you can say like the linear and the angular inductance transducers. Okay, so due to the changes of that position of the wiper, so what happened, that flux cutting also been changed. Okay, so flux cutting is changes, so you can see some of the output you can observe, and output also been changed. The change can be measured by the suitable circuit. Okay, that indicating the value of the input. Why would you made by suitable circuit? Basically, the amount of induced EMF may be less. Okay, to increase that value, to amplify that value, so you have to design some suitable circuit. Sorry, you have to design some uh, arrangement. Okay, for amplifying that value. That's why it is written like that, suitable circuit. Okay, and that value will be changes. Okay, that value will be changes with the presence of air gap. Okay, variations of self inductance. Okay, so variations of the self inductance. So the two coil arrangement is there. Okay, so two coil arrangement means here you can see variable self inductance. So on cylinder is there. Okay, so outer side, so core magnetic material. So core magnetic material is inside. Okay, that one, core magnetic material is there, and you can see that shaft. Okay, dotted line means that shaft is inside of this one. Okay, and the rest of the thing is non-magnetic material. So shaft normally means made by the non-magnetic material. Okay, so initial side. So here you can see that terminals of that inductance. Okay, so now if that points is changing, so definitely the inductance values will be changing. So it is two coil arrangement. Okay, in this method, so internal another coil is there. So what is written, a single coil with a center tap. Okay, single coil with a center tap. The movement of the core alter the relative inductance. Okay, so two coil in arrangement, what happened, that mutual portions also be considered. Okay, that's why it is written, the core alter the relative inductance of two coils. Okay, these transducers are incorporate an inductive bridge circuit in which the variations in the inductance ratio between the two coils provide the outputs. Okay, so I think I'll be able to understand. This is used to a secondary transducer. Okay, for the pressure measurement. Okay, due to the changes of that pressure, so what happened, that movement will be there, and that movement means there is a movement of your magnetic fields. Okay, so that may cause for the changing of your inductance value. So it is your variable permeability inductive transducers. Okay, so iron core is there inside, and the displacement, if the pressure is different, so that displacement will be different, and that will be moving inside of your ferromagnetic format. Okay, and you are able to get that output. Okay, and it is your coil, so coils are connecting over there. Okay, a single coil with the center tap, so both of the option is there. Okay, then what is variations of the mutual inductance? You know that two coils in mutual inductance, definitely there is an effect. So there minimum two coils are required, and there is an effect for current of coil 2 in the there is an effect to coil 1 with the presence of the current of coil 2, and the vice versa method may be followed. Okay, so here you can see two power coils are there. One power coil, so why it is called power coil? The exciter is connector, means additional voltage source is connecting over here, so that's why it is called power coil. And another coil is there, that is called pickup coil. Okay, to stage to circuitry. Okay, so if the current is flowing over there, so that current is flowing through this path, then air gap is there. Okay, so that flux line will crosses that air gap and coming to that former, and that will coming, so it will for completed that path. So another air gap is there, two air gap you can observe over here. Okay, so you can see that current is cutting to the current to the that current is cutting to coil 2. Okay, so the coil 1 current is cutting to the coil 2. So in this circuit you can see, so the inductance, two kinds of inductance may be observed. Okay, will be observed. One inductance is responsible. One inductance you can observe due to the current flowing this coil 1. Okay, due to the current flowing through the coil 1, so that may be there will be developed some flux lines, and that flux lines cutting, that flux lines is responsible for developing some induced EMF. Okay, so you are getting the induced EMF in coil 1 due to the self inductance, and additional induced EMF you can observe in coil 2. Okay, that means you pick up coils. Okay, that current, if the current is passing through from coil 1 current is passing through the coil 2, and that may cause for cutoff flux. Okay, so cutoff flux means, so induced EMF, that induced EMF is responsible, is developed due to the current of coil 1. So you can see that induced EMF is responsible for the mutual inductance. Okay, so two type of inductance you can observe. So it is written, that's why it is written two coil mutual inductance transducer. Okay, so here you can move, if that pressure will be different, so armature, so it is your armature. Okay, it is your armature, so armature is moving. Okay, so if the armature is moving, definitely that air gap will be varying. Okay, if that air gap is changing, so what happens? So that meter reading will be different. Okay, meter reading will be different. So by this method you can find out the variations, you can find out that value with the variations of the mutual, the using of that mutual inductance transducer. So what is written in this type, the flux from power coil. Okay, that flux from power coil is coupled to a pickup coil. Okay, which supplies the output, the input informations in the form of armature displacement. Okay, the changes in the coupling between the coil, the air gap between the core, the armature govern to the degree of coupling. Okay, so I think you are able to understand. So what do you mean by the degree of coupling? Okay, then variable reluctance transducer. So how that reluctance will be vary? Okay, so here you can see that air gap, if that air gap will differ, okay, if differ means changing, if air gap has changed, okay, then what happened, that mean reluctance, here you can see three reluctance path is there. The reluctance of that coil, that means core. Okay, so that core, the reluctance at the time of air, the reluctance in air, and the reluctance of the armature movement. See, reluctances are there. Okay, so the reluctance and differences is changing. Okay, so variable reluctance transducer means variable reluctance transducer used for the dynamic applications. Okay, so you can see one permanent magnet is there. Okay, so permanent magnet NS is there. Okay, so you are giving to you can see that armature. Now previous case, that armature face is smooth. Okay, there is no grooving, but here you can see there is some grooving. Okay, so there is some teeth. Okay, there is some teeth of your armature surface. Okay, due to that grooving, okay, so due to that grooving, so sometimes that air gap automatically it is changing. Okay, so what kinds of movement is there? It is horizontal movement. In previous slide you can see it is vertical movement, so here you can observe it is horizontal movement. Okay, so if that horizontal movement, so starred surface, okay, starred surface, so here you can see that movement is there, permanent magnet is there, so one coil is connected, that means to over that permanent magnet. So it is your connection, these two connection is directly given to the CRO for measurement, for the measuring of how much induced EMF is there. Okay, so lines of force will be from north pole to south pole, so it will be look like that, lines of force. Okay, so all that side it will be look like that. So a lot of here. Okay, so different is there. Okay, so there will be no cutting of any of the lines of force, but infinite numbers of lines of force that will coming from north pole to south pole. Okay, so then what happen in the variation of the air gap? Definitely that you can see that in CRO the reading will be different. Okay, so it is responsible for the changes of your inductor. Sorry, it is observed due to the changes or due to the variation of your armature surface. Okay, the a variable reluctance transducer is used for the dynamic applications. Okay, how do where the flux line supplied, okay, the flux line is supplied from where permanent magnet are cut by the turns of the coils. Okay, that coils are there, it will cut from here. Okay, some mean providing relative motions. Okay, so dynamic response is telling, so some relative motion is there, is included into the devices. The relative motion is there including to the devices. The figure shows the simple type of reluctance pickup consisting a coil and a permanent magnet core. Any variations of the permeance of the magnetic circuit cause the change of that flux. Okay, you know that Lenz law. So, or Faraday's law. It's not the Lenz law, it's the Faraday's law. Okay, which is brought about by a starred surface, okay, or group surface subject to the movement. As the flux field expand or the collapse, a voltage is induced in the coil of inductor. Okay, so I think all of you will understand the operations of this variable reluctance transducer. Now the most important thing at the time of exam, one question will be definitely there from linear variable differential transformer, LVDT. Okay, so the operating principle of LVDT, diagram of the LVDT and the working principle. Okay, so that is important at the time of exam, it will be there. Normal transformer, what happened here, core is fixed. Okay, in normal transformer your core is fixed, but in case of LVDT you can see that core there is a movement. Okay, so linear motions. Okay, so in core you can see that displacement, that core is moving. Okay, so it is your core is moving, and the three coil mutual inductance of the device in LVDT you can observe. So one is your primary coil. Okay, primary coil is there. So primary coil means that constant AC excitation voltage is given to the primary coil, like your transformer. Okay, three core transformer like that. Okay, so in transformer, normal single phase transformer, one primary coil is there, one secondary coil. Here you can see like that it is a three coil transformer. So first is your primary circuit, another two circuit is there, that is the secondary circuit. So normal transformer, what happens, so there is no variation of your core. Okay, so core is fixed, but in this study you can see that core is moving. Okay, so what type of movement is there? You can see that horizontal movement. So two secondaries are there, so one is secondary coil 1, another one secondary coil 2, and it is your sealed tubular body. Okay, tubular body. Okay, so some air is there, also some core is there. Okay, air and some core. So now as per the movement that you are changing the points of core, then what happened, that flux lines, primary flux lines and secondary flux line at the position of your core when the core is nearer to the in front of to the secondary coil. So full core is in front of the secondary coil, but partial core is present in the coil secondary coil number 2. Okay, full core is in front of that coil number 1, secondary coil number 1, and partially cover that secondary coil number 2. Then what happened? So primary coil always be there. Okay, so that then the flux line induced. Okay, so from primary coil to it is induced to the secondary coil 1 and partially secondary coil 2. Then this is condition number 1. Then condition number 2, that just reverse of your first condition, means core is in front of your secondary coil number 2 and the primary coil, and partially covered the secondary coil number 1. Okay, that also been possible. Okay, then both of the cases the partially filled. Okay, so like that. So as per your result, so you will get the difference voltage. Okay, difference voltage between induced voltage in secondary coil 1 minus induced voltage in secondary coil 2. So you will get some of the output voltage. So if you plot that graph, okay, so traveled area length is positive side, means 0, 5, 10. So one of them you are considering positive. So reverse thing. Okay, if you consider that positions covered by your core is 0 in secondary coil, 5, 10, then reverse thing means minus 5, minus 10, that also been observed in secondary coil 2. So we will get that output. So amplitude and the phase output. Okay, so you can see that it is your output voltage. So when it will be nearer to the positive coil number 1, so gradually that voltage will be increased. Okay, if that core is nearer to the secondary coil number 2, so the voltage gradually increase. Basically the difference of secondary coil 1 voltage minus secondary coil number 2 voltage. So when it will be nearer to a secondary coil number 1, then there will be less voltage in secondary coil 2. Okay, that's why difference, you will get the difference. Then reversing happen when that core is nearer to the coil number 2. So less voltage will be induced in secondary coil number 1. So it is negative side. Okay, and you can also find out the phase. Okay, so that secondary coil to primary coil. Okay, then from that diagram you can understand better. Okay, so primary AC input voltage is there, it is your core. Okay, so total secondary is splitted into two parts. Okay, so this one, that means coil 1 and coil 2. So induced voltage of coil 1 is VA and VB. So output voltage is there all the time, they are connected in series. So output voltage is there, VA minus VB. So here you can see the movement of the shaft, movement of the core. Okay, so core movement you can observe over here. Okay, so three conditions are there. Okay, so condition A, condition 0 and condition B. Okay, condition B 0 means when core is your movable core is just middle of your study, just middle of your study. Okay, so here you can see that displacement, some area is required for the residual voltage. Okay, so minimum voltage is required, that's why it is called residual voltage. So you can see gradually increasing that value, and phi is constant 0 at that position, and the displacement is reverse, so gradually decreasing, then it will be 0. Sorry, 180 degree, the reverse value will be there. It is your E0, means output voltage. So I think displacement and output voltage you are able to understand. So increasing the displacement in coil 1, so gradually increasing after that value with the presence of some residual voltage, and it is you can see that output voltage up to linearly increase that point A. Okay, then it is saturated. If the displacement in reverse manner, so definitely you will get induced voltage, but in negative dimension. That's why polarity you can say like the phase angle is 180 degree out of phase. So it is positive side, it is negative. So you have considered such a manner. So in phase and output out of phase. Okay, you can see that it is varying linearly. Okay, so core positions. Okay, and that output voltage is there. So rotating variable differential transformer. So previous one was a linear. Okay, now you can use some disc. Okay, inside of the two cores. So previously you are using shaft. Now you are making some rotational device. Okay, so that's why it is called RVDT, rotational variable differential transformer. So a RVDT is a type of electrical transducer used for measuring the angular displacement. Okay, that RVDT construction is similar to the construction of LVDT except that a concept, okay, a code replaces the code in LVDT shown below. So you can say that in between the primary and secondary, okay, is primary and secondary coil, you are getting one circular code. Okay, so that's why that value will be different. Then capacitive transducer, okay. So in case of capacitive transducer, okay. So the principle of this type is the variations in the capacitance are used to produce the measurement of many physical phenomena. Okay. So what type of different physical phenomena such as dynamic pressure, okay, dynamic pressure, displacement, okay, dynamic pressure, displacement, force, humidity, etc. Okay, so here you can see that K dielectric constant for AR K equal to 1, the area of the side of the plane, you know that things, okay, that equations, the equations of the capacitor, okay, so equal to K, that some constant always be there, okay, K n minus 1 into D, okay, so n is number of plates, okay, if there is multiple number of plates, then what happen, only one plate. Okay, so you can say that unit is in picofarads. Okay, so that separations of the plate in centimeter means d means the distance. Okay, epsilon a by d. Okay, in single form, in very simple form. A is what? A is the area of the plate. Okay, so capacitance is the ability. Capacitance is the ability of a body to hold the electrical charge. Okay, so in capacitor normally what happens? You are storing that electrical energy, and inductance what you are doing? You are storing that magnetic energy. Okay, so that's the capacitance. Okay, you can say like that. So in capacitance is also a measure of the amount of electric charge, okay, stored for a given electric potential. Okay, a common form of charge stored the device is a two-plate capacitor. Okay, if the charge on the plates are plus Q and minus Q, and the V gives the voltage between the plates, then the capacitor is given by C equal to Q by V. That's a common formula, you know that one. That SI unit of the capacitor is farad. Okay, so 1 farad equal to 1 coulomb per volt. So I think you know that one, you can already know the basic thing. Okay, so we are using that capacitive method for measurement and of voltage, maybe some current. So normally voltage. So that's why it is known as what type of transducer? It is capacitive. So it is your capacitive transducer. Okay, that's why it is known as capacitive transducer. Okay. Then in capacitive transducer, what is that operations? So here you can see that operating, that is opening. Okay, so liquid is there and in between, so central electrodes, okay, and hollow tube. Central electrodes, it is your central electrodes, okay, and it is your hollow tube. Two hollow tubes are there, so it is opening. So now we are going to open it. So liquid is there and central electrode. So capacitance pick up to measure the liquid level, okay, changing of the dielectric constant. If the liquid is entering, so what happens? The dielectric will be different. Okay, so normally what happens in the figure, so shows a device used for the measurement of a liquid level in a container. The capacitance between the central electrode and the surrounding hollow tube, so central electrode and the surrounding hollow tube varies with changing the dielectrics constant, both about the changing liquid level. So liquid level is changed, so dielectric constant also been changed. Okay, thus the capacitance between the electrodes is a direct indications of the liquid level. Okay, so you are able to measure that and you are getting that one. So direct indications of that liquid level. Okay, the variations in the dielectric constant can also be utilized for the measurement of thickness. Okay, so not like only liquid level measurement, you are also using for the measurement of the thickness, okay, of the dielectric constants, density, etc. So you are able to measure. So capacitive transducer in the torque meter. So how it will be work in the torque meter? So you can see that internal membrane and the sleeve membrane both are there. So the grooving is there. Okay, so you can understand well. So what how it will work? So air gap. So you can see that air gap. That air gap is varying. Okay. So one internal membrane. So it is your internal membrane. Okay. So with the teeth is there. Okay. So teeth all the time teeth is there, that you can see it's your air gap, but there is a difference. Okay, so air gap is always changing and it is sleeve. Okay, so two charges there, so D is changing. Okay, so epsilon L by D, na? So that formula. So A is the area of that plates. Okay, so that may be same, but the D is changing. If the D is changing, so capacitor is always be changing. So actually that capacitor transducer here it is used for a torque meter. So in torque meter how it is working? Okay, so that operation is written here. The capacitance, okay, that capacitance changes depends on the change of the effective area. Okay, so that air gap is changing, so definitely that D is changing. Okay, so effective area is changing. So this principle, okay, is use the secondary transducer element for the torque meter. So you know that different types of transducer is available, primary transducer, secondary transducer. So normally we are using in primary transducer directly you are getting that result from, there is no need for any calculations. Okay, but in secondary transducer you are using those different primary transducer for measuring the individual value. Okay, then you can use some mathematical tool to accommodate all those value and through a formula, and finally you will able to get the results. Okay, you will able to get the value that you are going to be measure. So in case of torque meter, same thing you can also measure. Okay, so the device, this device uses a sleeve with the serrations cut axially needs a matching internal number with the similar serrations along as shown in the figure. So that cutting portion is there. Okay, so that cutting portions, that is almost similar to your that internal membranes. That means points some coming out now, so that are similar to nearer to similar. So torque carried by the elastic member cause a shift of the relative positions. Okay, so that when it will be rotating, so it may cause for shifting of the relative positions of the serrations, thereby the changing of the effective area. So it's your area will be changing. The resulting capacitance may be calibrated to read the torque directly. So you can get some expressions, okay, of your torque. So if that length is changing, okay, so effective area has changing, so that may responsible for the changing of that capacitance. Okay, so you have some common expression that you need to be calculated, and you can place those value to that equations, and you are able to measure directly the respective values. Okay, so capacitor transducer, the capacitive transducer, that capacitive for the pressure is works like a pressure transducer, means you are using is a pressure measurement. Okay, so here you can see that fixed electrodes are there. Okay, fixed electrodes. So again capacitor measurement, so that voltage difference is needed. Okay, if that voltage difference is needed, so definitely that voltage you have to be given. So here you are going to be measured that capacitance. Okay, so movable electrodes, it is your movable electrodes. Okay, so this is your movable electrodes. Then it is a diaphragm. Okay, so diaphragm is there, so you are giving some of the pressure to the diaphragms. Okay, so diaphragm is moving, so that changing of the moving of the diaphragm, the changes of that capacitance. So D means distance is changing. Okay, so if that capacitor D is changing, so then what happened? The value of capacitance also been changed. Okay, that's a simple thing. So what is written? The capacitance varies inversely at the distance between the plates. Okay, so means if D is increasing, so capacitor will be decreasing. Means plate length is and the separation length of two plates is increasing, the capacitor value will be decreased. So if they are nearer to each other, so capacitor value is increased. So inversely proportional. So that is written that inversely proportional capacitance, capacitance vary inversely at the distance between the plates. Okay. The figure shows the capacitive type pressure transducer where the pressure applied to the diaphragms changes in the distance between the diaphragms and the fixed electrode which can be taken as a measurement of pressure. So how it is possible? It is only possible changes of the pressure. Okay, so if the changes of the pressures you can observe. So diaphragm will be moved due to the pressure. Okay, so that if it is moved, so the entire process, the d is changing. Okay, the d, if that value is changing, then what happens? The d is changing. If that, it may be that fixed, it is a movable points. Okay, but fixed electrode may be fixed. Okay, it is not changed. Okay, the fixed electrodes always be fixed. Okay, it is not changed, but which portion, which values are changing? So capacitance are changing. Okay, then the distance are changing, and that distance changing is responsible for changing of the capacitance. So what are the advantages? Okay, advantages of capacitor transducer that we need to know. So so what you can see, that it requires extremely small force to operate and highly sensitive. So that's why it is quite costly. So very small variations, it may deflate the pointer, or you can store that value. Maybe amplifications are required, but very small deviation, that field changes are there. Due to the field changes, okay, so we are able to face that value. So it is very sensitive. Okay, so very good frequency response. Okay, very good frequency response, hence helpful for the dynamic measurement. So maybe frequency, time domain response, okay, depends upon your response time. Okay, so response time good means definitely that measurement means dynamic measurement also very helpful, also very better compared to the other instruments. Okay, so first point I have discussed, second point I covered, then third point. Okay, so high resolution. Okay, so in single point high resolution can be obtained. Okay, point number 4, they have the high input impedance, hence the loading effect is minimum. Okay, maybe loading effect is minimum, but high input impedance. Okay. Last point of advantage, this transducer can be used for applications where the stray magnetic fields render the inductive transducer useless. Okay, so for stray magnet in your LVDT, the problem is that residual magnetism. So there is some magnetic additional field is there. Okay, so it will direct effect to your measurement. Okay, definitely all the measuring instrument having such kinds of problems, so you have to prepare one independent atmosphere for measuring purpose, like your sophisticated measuring purpose. Okay, not like normal laboratory measurement in our UG level, means undergraduate level lab. Okay, so normally what happens, that resolution is good, means moderate, accuracy also means moderate. Okay, not very poor, not very. So but we have to perform the experiments. Okay, now, so but in sophisticated analysis, then what happens, the external field having some influence to your system, so that's why your system should be isolated from the external fields. Okay, that another important point. Then what are the disadvantages of capacitor transducer? Okay, so metallic part must be properly insulated and the flame must be earthed. Okay, so otherwise what happens, frame is not earthed, so actually you are going to measure that voltage na, so difference is if zero, so there will be no problem because you are measuring that value in terms of reference value. That's why that reference value should be make it earthed, means zero potential, you should keep it in zero. That's why it should be earthed and reference value should be zero. Okay, then there is a problem, but here lot of metallic plates are used or paths are there, so that may reduce that value. Okay, some problem may occur. Okay, they show the nonlinear behavior due to the age effect Drinks must be used as a eliminated effect. So what do you mean by non-linear? There that linear variation, that those parameters are varying linearly. Okay, so due to the non-linearity, they are not directly varying that linearly. Okay, so some of the saturations type of non-linearity, or the for very initial stages, some of the cutoff region is there. Due to the presence of this cutoff regions, then what happened? Then limitations, working possibilities zone. Okay, so it will not suddenly start it. Okay, it will take some time. The response time will be dropped. Okay, that's why some initial non-linear behavior it is observed. Okay, and then they have the sensitive to temperature, effective their current performance. Or most of the instruments are being temperature sensitive, so definitely there will be a adverse effect for their performance due to the temperature. The instrumentation circularly used with these transducer are complex. The circuitry, so definitely that lot of complicated work you are doing. So with a single transducer, so it's mandatory that there is some effect of temperature. Suddenly the temperature is changing, so there will be a effects. Now it is common sense. Okay, the instrumentation circuitry used for the transducer are complex, so that's why circuitry quite complicated. The capacitance of these transducer may change with the presence of dust particle and moisture. So if you make it in keep it in open atmosphere, then there is a effect of aging. For what? Aging effect is coming due to that dust particles. Okay, that available dust particle in our environment. Okay, and the moisture. So moisture also is has some detrimental effect to your sensors or the transducers. So that is another big disadvantages that you can observe in case of transducers. Okay, so what type of transducer? Capacitive transducer. Still the benefit is more, so we have to use this type of transducer. So I think this is enough for today's class. Okay, so next class I will start another portion. So till now, if you have any doubt, you can ask me. Okay, so I think no one is asking me, so maybe there is no doubt. Okay, so I have covered that up to capacitor transducer. So next class I'll discuss about piezoelectric transducers. Okay, so and piezoelectric transducer, then piezoelectric different types of piezoelectric transducer, then digital transducer, Hall effect sensors, means transducers. Okay, that portion I will discuss in my next class. Okay, so till now, if you have any kinds of and the different applications, okay, examples, if you have any kinds of doubt, you can ask me. Okay, so I think the chapters are not so complicated or difficult, so it's a more or less theoretical chapters. Okay, so you can understand well. Okay, if you study well in your home, so I think you can understand well. So I all the time I suggest all of you, please prepare your class note up to date. Okay, so I think you are doing it in your home. Okay, so tomorrow, okay, so today I am stop my session.